Hi guys, so in this video we will be solving this problem, shortest bridge. So first let's understand what the problem says. So we will be given a binary grid of zeros and ones. So here one represents island, group of island. Like here this is a group of island and this is a group of island. We can flip these zeros into ones and we have to tell what is the minimum number of flips required so that we can connect both of these islands. So what I meant by it is, what we can do is that we can flip these two zeros. One way is that we can flip these two zeros. So if I flip these two zeros, what I will get? I will get 1 1, and I can see that it is a group of island, right? So this is one option. One way is this. So what was the minimum? Minimum equal to 2 was the option for this. Now is there any other way? Yes, there are other ways also. What we can do is that instead of flipping these two zeros, I can flip this particular zero here also. Now also I'm able to connect these two islands, and this time I am using only one flips. So 1 is less than 2. So I have to tell the minimum number of flips in which I can connect these two islands. One more thing, if I am at a particular one location of at 1, what I can do? I can move in the 4 adjacent directions, means I can flip zeros in these 4 adjacent directions. Okay, so I guess the problem would have been clear till now. So now let's move on to the solution, okay, approach, like how we can solve this problem. Suppose if this is the group, if this is the question, so here there are two group of islands. This is one group of islands and this is the second group of island. So either I can try to move from group 1 to group 2 or group 2 to group 1. That is, I will try to find the minimum number of flips that are required from group 1 to group 2 or group 2 to group 1. Both will give the same answer only. So we'll start from any one. Okay, so let's suppose if we start from group 1, so there are 4 ones in this particular group. So, and if I am at a location of 1, I can move to 4 adjacent directions. So I don't know like which particular one will give me the minimum answer. Anyone, if I start from this location, it could give me the minimum answer, or this one, I don't know in advance. So what I will have to do, I will have to consider all the options in a particular group of island. Let's take an example what I just now said. If we start from this particular one, let's see what are the minimum number of flips required. So we can see that I will have to flip this particular 0 into 1 and this particular 0 into 1. Then I will be able to connect this group of islands, right? All ones are there in this group of island. This in this one I had flipped two zeros. Okay, now let's see one more example. If I start from this particular one, then I will have to flip only 1 0. Now also I am getting a group of island. If you see clearly, this is the group of islands. So here I was getting only one, so I don't know like which one will give me the minimum answer. So I will have to consider all the 4 options. So what I will do is that I will start from any one, like any one. If this position, I will apply DFS and I will find all the neighboring ones. That is, I will find all the locations of a island. Like if I start from 1, this is the group of island 1 1 1. So I will find 0 1 2, give me a second, 0 1 2, and let's check, index it 0 1 2 3 4 and 5. So what I am saying is that we will traverse this matrix, and whenever we will find a 1 represents is what? 1 means an island. So I will move in all the 4 radial directions, and I will try to, means I will apply DFS and find the locations of all the points which are connected by this island. So if I apply, I will get what? I will get 0 1 0 2 and 1 0 1 0 and 1 2, not 1 0, 1 1 and 1 2 are a part of island. So I get this. So all these are my valid options. Any one of these can give me the minimum answer. One more thing, if you look clearly, what we are doing is that if this is a group of island and this is a group of island, what we were doing, we were moving one step, okay, we were converting it into 1, then again moving one step, we were converting it into 1, we were moving it till we were not able to find a 1. after this point, what I'm seeing, if I'm moving to the next element, I'm seeing that it is a 1, it is a 1. Okay, so 1 represent what? 1 represent that it is an island, so I have reached the other island. So what if I consider these as edges, what we are seeing, that one by one we are moving radially in all the directions, one step at a time. That I can consider this edge. Okay, so I'm basically finding minimum, like minimum edge distance. So whenever we have to find minimum edge distance or something like this, what we use BFS, right? So the same we are going to use over here also. We are going to use BFS for solving this particular problem. Although like it is natural, you might have getting idea like we can apply BFS also, but we can see it in this way also. Like if you consider, like if this is an edge, means it is a block, it is another block, one by one we are moving radially, one step at a time, so we can consider it as an edge. So we have to find the minimum shortest edge. So for finding shortest edge, what we apply? BFS. So the same we are going to use. So what we will do, we'll maintain a queue. Okay, and initially let me redraw this matrix. Okay, so it is what? 0 uh 0 1 1 0 1 1 0 1 0, sorry, 0 1 1 0 1 0 0 0 0 1 1. Let's erase this one. Yeah, so what we will do is that 0 1 2 3 4, initially we will store all the points, starting points. Okay, and we will mark visited also. Like in applying BFS, we used to we mark visited so that we don't visit the same cell again. So we will mark them visited also. So let's store the all the cells. So let's suppose what is the index of this particular one, it is what? 0 comma 1. So we will store 0 comma 1. This particular is what? 0 comma 2. We will start, will whenever we will find a 1, we will apply DFS and we will find all the connected components, like whichever zeros or whichever ones are adjacently connected to each other in the 4 direction. We will collect the indexes of all those indexes and we will store it in a queue. So what we will get? We will get 1 1 and 1 2. Okay, so these are the collected, so these are a part of a island. Okay, and we'll mark them visited also. So let's mark them visited. This is visited, this is visited, this is visited, and this is visited. After this, what? Any 4 of these can give me the minimum, like minimum number of flips required to connect both of these islands, and each time I will move to the 4 directions 1 unit. So what I will do, one by one I will move and I will keep a counter. Okay, let's take a variable level. I will increase the level whenever I will get a 1. That means what? Let's suppose if I start from this point, what I will do, I will move to this point. I see it is a 0. That means I am in the middle area. Again I will move to the next point. Oh, I see what I saw. I reached 1. That means what? 1 means what? An island. So here originally it was 1, and in the second part it means there was island. So if I have reached a 1, that means what? I am able to connect the island. So I will return whatever is the will be the value of level at that particular time. Okay, so let's see this in action. How will it actually work? Okay, let me erase this. So initially all these 4 points are visited. After that, what we will do, we will one by one remove the elements. 0 comma 1 will be removed. Okay, 0 comma 1 will be removed. We will move to all the 4 possible directions up. If we move up, we will be out of the grid, so we will not move over there. If we move to left, okay, so we see we are visiting 0. So this is a 0, so we will add it back to the queue. Current our level value is what? Level value is 0. So all these 4 elements are at our current level. Okay, level value is 0. Now 0 comma 0 will be added into the queue. Let's add it with different color. Okay, now we will move in the down direction. From this particular point, if I move down, I am seeing that it is already visited, so no point to move. From this particular point, we have moved up, left, down, and if I move right, this is also already visited, so no point of visiting. Okay, now again remove the next element from the queue. What we will do, 0 comma 2. Now this is the point 0 comma 2. Let's move in the top direction. If you move it in top direction, what we are seeing is that what? It is out of the grid, so we will not move. If we move in left direction, then we will reach here. It is already visited, so no point to move. If you move in down direction, it is already visited, so we will not move. If you move in right direction, we are reaching to 0 comma 3, it is not visited, so we will mark it as visited, and it is 0, that means we are in the empty area, so we will simply add it back to the queue. So 0 comma 3 will be added into the queue. Okay, now remove the next element. Next element is what? 1 comma 1. Next element is 1 comma 1. So 1 comma 1 is over here. If I move in top direction, it is already visited, so no point in visiting back again. Move in left direction, I am visiting to what? 1 comma 0, it is not visited, mark it as visited, and 0 represents it is the area in the middle of, means it is area somewhere between two islands, so we'll add it back to the queue. So 1 comma 0 will be added into the queue. 1 comma 0. Okay, now next we'll move in downward direction. From this point we'll reach to what? 2 comma 1. So 2 comma 1 is not visited, mark it as visited, it means it is 0 and it is somewhere between these two islands, so add to the queue 2 comma 0. Next element, next is what? We'll move to the right of this point, but right is already visited, so no point in visiting back again, so it is also done. So let's erase this part. Now remove the next element from the queue. Let's shift the queue little over here. Okay, now remove the next element. Next element is what? 1 comma 2. So next element is 1 comma 2. If you move in up direction, it is already visited, so we will not move. If you move in left direction, we are seeing it is already visited, so no point in moving over there. If you move in down direction, so we are reaching to 2 comma 2. So 2 comma 2 is not visited, mark it as visited, it is 0, that means it is somewhere between both the islands, so we will add it back to the queue. So 2 comma, what is this point? 2 comma 2. 2 comma 2 will be added into the queue. Okay, now let's move in the right direction. So right direction will be what? Right direction is 1 comma 3. 1 comma 3 is the right direction, so 1 comma 3 is already not, also not visited, so let's mark it as visited and add it into the queue. So 1 comma 3 will be added. Okay, now we have exhausted the first four elements. That what does it means? That at each of these four locations 1 comma 1, I have tried to move in all the four directions in one unit. Like I have tried these all directions one unit, and I am not able to, not these ones, yeah, in all these four directions one unit, so I am not able to get what? Any single one in 1 unit radius, means in 1 unit I am not able to get that. That means what? Sorry, in 0, like in simple flip, I am not able to get this particular anyone. That means what? I have not reached the another island till yet. So what I will do, I will increase my level by 1. Okay, now I will remove one by one, move 1 unit from these points. I will check whether I am reaching the level or not, I am reaching the another island or not. If I get a 1 anywhere, that means what? I have reached the other island. So this is the flips which I am required. But if I am not able to reach one, that means what? I am still in the middle of both these two islands where there are zeros, so I need to flip more zeros. Okay, so let's continue with our algorithm. So our level value is 1 incremented. We have exhausted the first four elements, so we incremented our level by 1. So now let's remove the next element. Next element is what? 0 comma 0. 0 comma 0. So I can go in the top direction from 0 comma 0. Like if I am over here, I can move in the, sorry, 0 comma 0 is over here, sorry, 0 comma 0. I can move in the top direction, so this is out of the grid, so I will not go over there. I can move in the left direction, this is also out of grid, I will not go over there. Okay, I can go in the downward direction, but it is already visited, so we will not go over there. And yeah, only these four options. Yeah, and I can go in the right direction also, but right direction is also already visited, so we will not go over there also. So no possibilities for 0 1, so it will be simply removed. Okay, now since we have done with these elements, let's erase these elements for now, and let's shift the queue left direction in the leftwards, so that we will be able to add more elements. Okay, yeah, let's remove the next element. Next, 0 comma 3. So 0 comma 3 is the next element. 0 comma 3. Okay, so I am at this particular location. I can move in the upward direction, but I will be out of the grid, so I will not take this one. I can move in the left direction, but it is already visited, so I will not move over here. and I can move in the downward direction, but it is also already visited, so I will not take this step. Then I can move in the right direction, so I will reach to what, 0 comma 4. 0 comma 4 is not visited. Okay, we'll mark it as visited, but what we are seeing is what, 0 comma 4 is what, 1, and 1 represents what, an island. And I have started with this group of island, that is from left group of island. Okay, and what I am doing is that one by one I am moving one step, and I am converting 0 into 1, converting 0 into 1. But this time, what is happening? When I reach to this point, this is what? This is already 1. That means what? I am able to connect these two islands. Since in the middle, whichever 0 was present, I had already converted into the 1. And this is, and I have reached a 1. That means what? I have connected these two islands. So I need to stop. I'm no longer required to calculate more. Whatever the current value of level, it is the minimum value. Why? Because we are using BFS technique, and BFS gives the minimum length. So whatever current level is there, we will simply break our iteration and simply print whatever is the current value of level. So, and so according to our algorithm, what we are getting is 1. And if we check also, or in our dry run also, what we have saw, that 1 is the answer for this case. Let's see that also. This is the matrix 0 1 1 0 1 1 0 0 0 0 0 0 1 0 1 1 1 1. According to our algorithm, only one flip is required. And if we see, if we simply flip this 0 into 1, like this 0 into 1, what we are getting, we are getting this group of islands, like we are able to connect it by simply one flip. So this BFS technique is working fine. Okay, so what all we are going to do, like let me recapitulate it again. What we will do is that in our algorithm, whatever we'll do, we'll traverse this matrix, whenever we will get a 1, what we will do, we'll apply DFS, and we'll find all the connected components, like all the ones which are connected to each other adjacently, DFS, and we will store it in a queue, like store the locations on a queue. After that, what we will apply BFS to all these elements, and we will move 1 unit radially in all the four directions till we encounter a 1. When we encounter a 1, what does it represent? That we reached the other island. So we'll simply return our whatever is the value of our level, that will be our answer. Okay, and once all this DFS, suppose if there is a case, let's suppose there is a case something like this 1. Okay, there is a case 1 over here. Yeah, only there is only one island. Suppose there is only one island, no more island. So will we be ever be able to reach other island? What will happen? We'll one by one travel from here. We'll convert it. We'll not convert, like we'll travel one direction, then we'll move over here, but we'll never be able to reach any other one. So in this particular case, if after all this iteration, when this BFS ends, we will simply return what, -1. That means what, there is only, means no possible answer if there is such case. Okay, so after whole this algorithm runs, our queue gets empty, and if we are not able to find any value for level, that means we will return -1. Okay, so I guess this algorithm would have been clear to you. So now let's try to code it, and let's see whether it is working or not. Okay, so now let's code this problem. So we have given this function, we have to write this. So let's name this array as array. So what all we are required to do, let's see. First we will traverse the matrix, then apply DFS. Okay, so let's make a queue of pair, y pair. Let me explain you that as well. As you can see that what we were storing in the queue, like index I comma j. So for that we will be requiring object. So we'll make an object of pair class. Let's make a class also for that. Let's take class pair. Let's make row, which represents current row, and column. Let's write the constructor for it, integer row and integer column. This dot row equals to row, and this dot column equals to column. spelling mistake. Okay, now we can make a queue. Okay, after that we are traversing the matrix and storing it using DFS. So let's traverse the matrix. We'll need a variable. Let's make a variable boolean. Let me, yeah, now we can code it. Let's make for integer I equal to 0, I is less than array dot length plus plus I. Since we need to traverse the matrix, we will run two for loops. J is less than array 0 dot length plus plus j. We will check if array of I comma j is equals to 1, then it means what? It is a part of an island. So we will apply DFS and we will collect all indexes of all the one blocks. Then we will make flag equals to true. Then we will simply break the loop. Spelling mistake, flag. Okay, and here we will check outside that if flag, then simply we can break it over here. Okay, now let's write our logic for our DFS functions. Public static void DFS. We have a queue of pair class queue. Along with that, we will require the source row and source column for where we are currently standing. We will also require a boolean array visited and our main array, that is array. So let's pass these in parameter also. The queue along with source row is I, source column is j. We will pass the visited array and the main array. Let's make a visited array also. Boolean two-dimensional array visited equals to new boolean of array dot length and array of 0 dot length. Okay, so we are done with this. Now let's write the logic. So what we do in DFS, first we mark the node as visited. So let's mark this cell as visited. Then let's add it into the queue. Queue dot add new pair of source row source column. It will be capital P. Okay, after that what we will do, we'll move, like if we are at a point, we are allowed to move in the 4 directions. So for that we'll have to make a direction array. So let's make a direction array. Let's suppose 2 direction arrays, static integer array dx and static integer array dy. Okay, this we will use to traverse. So if I can move in the 4 directions, so this is what -1 comma 0, this is what 0 comma plus 1, this is what +1 comma 0, this is what -1 0 comma -1. So my dx is what -1 0 1 0 and my dy is what? Dy is 0 1 0 -1. Okay, so let's write it. So dx is -1 0 1 0 and dy is 0 1 0 -1 0 1 0 -1. So now we'll move in the 4 directions. So for integer I equal to 0, I is less than dx dot length plus plus I, we'll calculate row. Row will be what? Our current row, that is source row, plus of dx of I. Our column will be what? Our current column, source column, plus of source column plus of dy of I. Okay, so we are moving in the 4 directions. We have to check that whether these are valid locations or not. So we will check if row is less than 0 or if column is less than 0 or row is greater than equals to array dot length or column is greater than equals to array of 0 dot length. Then these are what? Out of the boards, so these cannot be a part of the island. So we will skip these nodes positions. We will simply mark them as continue. Other than this, what we were checking, that whichever cell we are visiting, if it is already visited or not, yeah, that we can check later also. Let's check what all checks we were doing. We were moving the four directions. If it is already visited, then we will not go over there. And if it is 0, like if array of this row where we are going, it is 0, that means what? Simply continue not to visit this node since it is not a part of island. Finally, we will check if it is already visited, that if this particular row is not visited, then we'll apply the DFS call to it again. So DFS of q, row will be what? Our row, column, and visited will be passed as it is, and array will be passed as it is. Okay, so our DFS function is done. After this, what we need to do, we can see after DFS storing the indexes, what we will do, we will apply the BFS. So let's do the BFS part now. In over here, for BFS we will require a variable level. So let's apply BFS while q dot size is greater than 0. What we will do, first let's calculate the size. Size is what? Q dot size. And while this variable size is greater than 0, one by one we will remove the element. So q dot remove. Okay, after that, again what we were doing, from the removed element we are moving in all the four directions. So let's do the same part again. So for integer I equal to 0, I is less than dx dot length plus plus I, what we will do, this part will be what? Same, this much will be same, copy 12c. Let's paste it over here. We calculate source row, source column. We will check if it is out of bound, then we will simply skip this node. We will also check if it is already visited, if visited of row comma column, if it is already visited, then also we will simply check it. Otherwise, what we will check, if the current location where we have reached array of row comma column, if it is equals to 1, that means we have reached the island. So what we will do, we will simply return the current level. Otherwise, what we will do, we will add it into the queue. Q dot add new pair of what? Row comma column, and each time we will increment the value of level. And if the queue gets empty, our BFS is over. That means we are not able to find the one, that we, in that case we will simply return -1. Okay, so let's check whether we have done everything correctly or not. So we need to traverse the matrix. So we are doing over here, we are traversing the matrix, and whenever we are getting a 1, we have called the DFS function. Yeah, one more variable, boolean flag equal to false. Now we had made it true. Yeah, so we have called the DFS function for all the locations of this particular island. Okay, so DFS gives us that. After that, what we have to do, we have applied this BFS logic, we have incremented the level. Let's check whether we have written everything correctly or not. So we are moving the elements, we are moving in the directions. If it is out of board, then we are skipping it. If it is already visited, we are skipping it. Yeah, we can mark it as visited also, and we have visited it. Okay, finally we are adding the element where in the DFS also we are first marking it as true, we are adding it into the queue, and we are moving in the four directions. If it is out of board, then we are skipping it, and if it is 0, then no point of visiting that node. Okay, otherwise if it is not visited, then we are calling DFS. Okay, so let's now try to run this code. Let's see whether it is working fine or not. So there is some error, cannot find symbol R, source row, where it is line number 64. Line number 64, R equal to source row. So it will not be source row over here, it will be removed element dot row, and it will be removed element dot column. I copy pasted the code, that's why there source row and source column, these two errors were there. Now let's try to run the code. We are getting correct answer. Let's try to submit it. So let's see whether it is passing. So the solution is correct. I hope you guys would have enjoyed the video.